So yesterday, when I asked you guys to do an exploration in the student journal for 8.3, I hope that you went to Desmos and you plugged these guys in and you came up with graphs that looked something like this. And when you did, you hopefully you were able to answer the questions on the next page in the student journal. Let's go ahead and take a look at that. So there were questions like, what do you notice about the x-coordinate of the vertex on each graph? Well, let's take another look in Desmos. Here's a vertex, and the x-coordinate is 2. And here's a vertex, and the x-coordinate is also 2. So let's go ahead and, if you didn't write this down yesterday, let's write it down now. If I look at the vertex for both of those parabolas is at 2 comma something, whatever it is. Okay, next, use the graph of y equals 2x squared minus 8x to find its x-intercepts. Verify your answer by solving. Okay, so let's look at the graph and find the x-intercepts for this guy. So again, in Desmos, the y equals 2x squared minus 8x is the red one. So the x-intercepts for the red one are going to be at x equals, let's see here, it's going to be at x equals 0 and x equals 4. So let's go ahead and answer that question. Let's get back to this. So the x-intercepts are at x equals 0 comma 4. And then they say verify by solving this. Well, let's try solving this. So I'm going to write my work up here. 0 equals 2x squared minus 8x. Now, some of you folks may not remember how to solve this guy. The way you do it is by factoring the GCF, and then we'll use the zero product property. So we do 0 equals, and we'll take out the greatest common factor. So I'll take out a 2, and that gets me x squared minus 4x. That still looks to me like we still have more that we could factor out from that that's common. So I'm going to take an x out of both of those terms. So 2x times x minus 4. And then the zero product property says if I multiply things together and I get 0, then one of the things has to be 0 or the other thing has to be 0. So I'm going to go ahead and set 2x equal to 0 and set x minus 4 equal to 0 and solve both. In this case, it looks like x equals 0 divided by 2, which means that x equals, some people think it means no solution, but you can divide 0 by 2. You should try it on your calculator. You get 0. So x either equals 0 or add 4 to both sides, x equals 4. And so what we say is x must equal 0 or 4. And you'll notice that that is what we wanted to do. We wanted to verify our answer, and sure enough, x equals 0 or 4. Okay, now, one of the reasons they ask us to do this in the student journal is they're hoping that we can begin to put 2 and 2 together, that the x-intercepts of a quadratic function also happen to be the solutions to a quadratic equation when y equals 0. Okay, so if you didn't get that, that's okay. Slowly by slowly, I'm just going to keep exposing you to this stuff over and over, and we're going to look at it from different angles until you're like the master. Okay, so next, compare the value of the x-coordinate of the vertex with the value of the x-intercepts. Well, the x-coordinate of the vertex was 2, and the coordinates of the x-intercepts are 0 and 4, and they ask us to compare them. Now, honestly, I'm not entirely sure what the authors of this book wanted out of this, but I will give you my take on this. It seems to me this 2 is halfway in between the 0 and the 4. And if you notice that, you're a genius. Good job. So that's what I'm going to write. I'm going to say 2 is halfway between 0 and 4. And we're going to use that exploration from yesterday as a jumping off point into what we're going to do today. Okay, guys, so now I'm going to throw a few things at you kind of quickly, and I apologize for that. And when we get together in our next meeting, you will have the chance to ask me any questions for clarification. So first, I'd like to point out that in that function that they gave us, the y equals 2x squared minus 8x, they forgot to point out that this is in the standard form for a quadratic equation, which is y equals some number times x squared plus some number times x plus some number. In this case, the number on the end is really just plus 0. Um, and so if they had pointed that out to us, something interesting that we might have discovered is that when we wanted to find the x-coordinate of the vertex, remember the vertex right there? If we wanted to find the x-coordinate of the vertex, it's just halfway in between these two guys right here. And it turns out one way to find that is to take this middle number, the negative 8 or b, and divide it by the first number, a, and unfortunately that's not quite good enough. So we'll do something like x equals negative 8 divided by 2, and that gets us negative 4. The problem is that is not the x-coordinate of the vertex. But if we divided that by 2, we would get we'd have to do two things. We'd have to divide by 2, and we'd have to make that a positive. So what we can do is we can kind of establish a little rule here, is that if we so forget about this for just a second. If we took that middle number, negative 8, and we changed the sign of it, in other words, we took the negative of it, and then divided by not just 2, but 2 times the 2, then we would end up getting positive 8 over 4, or 2, which is the actual x-coordinate for the vertex. We're going to generalize this and make it into a rule or a formula, and the formula goes like this. The x-coordinate of the vertex of a quadratic function or a parabola will always be negative b over 2a when the quadratic function is written in standard form. We will always be able to find the x-coordinate of the vertex by doing negative b over 2a, and that's what they show on this page here, is that this line that goes down the middle of the vertex, and by the way, that line is at some x-coordinate, that formula is x equals negative b over 2a. Now, that dashed line happens to have a name. It's called the Axis of Symmetry, and we'll abbreviate AOS because it's a real pain writing Axis of Symmetry over and over again. And by the way, who even remembers how to spell symmetry? Okay, so we're going to put this into our little basket of tools, along with other things that we know. And by the way, that we'll label that. That's the AOS. And we're going to pick up a couple more things in this lesson, and then we're going to apply them with some practice problems. All right, so we've got problem 1, 2, 3, and 4 here, and all they ask us to do is find the axis of symmetry, and then find the vertex of the graph of the function, just those two things. I'm going to use one of these as a demo. I'm going to try number 3 because it looks kind of complicated, and then you're going to do 1, 2, and 4 on your own, or together with me, either way, later on. But let's do 3 together right now. We'll do it kind of as like notes. And so 3 goes like this. If we want to find the axis of symmetry, we'll do x equals negative b over 2a. And in this case, we've got a equals negative 2. We've got b equals negative 8. And strangely, we can ignore c altogether. So this will be negative b, so that'll be negative 8. And that is all over 2 times a, so 2 times negative 2. That's a whole lot of negative signs, people. X equals negative 8 is the same as positive 8. And then 2 times negative 2 is negative 4. And that gets us negative 2. So to answer the question for 3, the AOS it can be described as a line where x equals negative 2. Now, I'm going to remind you that that axis of symmetry is a vertical line, and this is related to something we talked about a long time ago called Hoy-Vux. Hoy-Vux just tells us that if we have a vertical line that we're going to have an equation that is x equals some number, and sure enough, it's still true to this day. Yay. Cool. Okay, next, we got to find the vertex for problem 3. Well, we've got the x-coordinate of the vertex. The AOS is the x-coordinate of the vertex. So in order to find the rest of the vertex, we're going to do f of x is equal to negative 2x squared minus 8x plus 5. And the way that we're going to figure out what the y-coordinate of the vertex is, this is y, by the way, don't forget, f of x is y, we're going to use synthetic substitution. So we're going to go ahead and plug in negative 2, x is our negative 2, so we'll do negative 2, and where did that come from? Right over here, okay? That's where that negative 2 came from. And then we're going to throw this negative 2 over here, and this negative 8, and this 5. And this is all part of the concept called synthetic substitution. So negative 2 plus nothing is negative 2. Negative 2 times negative 2 is positive 4. Negative 8 plus 4 is negative 4. Negative 2 times negative 4, positive 8. That gets us 13. And voila, you now have the ability to do problem 1, 2, and 4. Now, I will tell you this. I'm already feeling like this video is getting a little bit long, so I'm going to end it. That's the whole video for today, and all you got to do is go in and try to find the axis of symmetry and the vertex of the graph for 1, 2, and 4 on your own. And again, if you can't do it, if this lesson was not good enough, you're going to wait and you're going to do it together with me. But you have to be brave and you have to ask me to help. Otherwise, I won't know that you need it, and I don't want to force it on you. Okay, so let me go ahead and finish this off by writing this out. So the vertex is at, oops, that's not a good at symbol. The vertex is at negative 2, comma, 13. Where'd the 13 come from? Right over here. There you go. That's where the vertex is. So now that's the second part of our answer. And just to be safe, I noticed that I have the word vert here and vertex right there. This vert meant that we were talking about a vertical line. Okay, that's the Hoy-Vux thing. H is for horizontal, you get an equation y equals. V is for vertical, you get an equation x equals. Okay, people. Whew, man, this is some crazy stuff, but it's really good for you. This is like eating your spinach or doing push-ups, okay? This is good for your brain. See you soon.